Alright guys, here's our part 2 of our video for our chapter 4 review. Okay, so we're on the back page here. One thing, if I did not mention this in class, which I should have, please change this 3x minus 17 or minus 21 to a 4x. You'll see why in just a few minutes. Find the values of x and y. Now, normally, the three angles of a triangle add up to 180. Well, normally, they always do. The problem here is if I add these three things up and set them equal to 180, I have two x's and I have a y, which I can't solve. Luckily, they tell us that these two sides are the same, so we know these base angles must be the same. So I can do 4x minus 21 equals 2x plus 17 first. You never want to make an equation up with two variables if you can avoid it. Now, if I subtract 2x over, 2x minus 21 equals 17. I can add 21 over. 2x equals 38. Divide both sides by 2. X equals 19. Alright, sweet. If I take this and I plug it back in, let's take a look what happens. 2 times 19 plus 17. Okay. 2 times 19 plus 17 gives me 55 degrees. Okay. So I get 55 degrees right here. And then over here, if I do 4 times 19 minus 21, I get 55 degrees as well. Alright, now we're on to something. So the three angles of a triangle up to 180. Okay, so now I have 55 plus 55, which are these two angles. If I add that with 3y, that has to equal 180. 55 and 55 is 110. Subtract that over. 3y equals 70. Divide. This is going to end up being a decimal, but 70 divided by 3. Oops, sorry. 23.33. Okay. Very, very nice. We can plug that back in and see it just works out just fine. Alrighty. Find the values of x and of y for number 7 down here. So, this is a straight line, much like I did the other video, straight across. So I know that 180 minus 127 gives me 53 degrees. So here's 53 degrees. Now again, it's kind of the same principle as the above one. These two are the same. So if this is 53, y has got to be 53 degrees. Now, triangle is 180, so 53 plus 53 plus x equals 180. This gives me 106. I could subtract that over. X equals 74 degrees. So up top here, I got 74 degrees. We're in good shape. Alright, the last and final part here. These are all 5 of the theorems that we learned in class. And as I mentioned to you guys, we're going to give you a little word bank here. SSS, SAS, AAS, ASA, HL. If it's not possible to prove triangles congruent, write none. You can write not enough info like we talked about in class, but here we go. Number 8, okay, we have these sides congruent. Also, I would be telling you in class that 1 and 2 are congruent. So is there any other side or angle that's congruent for this picture? Well, hopefully you guys have a reflexive property in the middle. There we go. So because I have two sides the same, right, and they meet right here, and the angles between them, this is SAS. Alright, and just to kind of label everything for you again, because we've been doing this in class, AD is congruent to BC, angle 1 is congruent to angle 2, and AC is congruent to AC. There's your partial credit you can receive for that. Okay, very, very nice. Part B, okay, if I look here, yes, the angles in the middle are congruent. There's an issue though. Is there anything else in this picture that they give you? No, that's all they got. So this one would be your not enough info. I can't say any of the sides are congruent because nothing's given to me. So just based off of what the picture is there, that's all we got. Okay. Part C. I have side, so I have WX is congruent to YZ. I have XY is congruent to WZ. And if I'm looking for a third side or a third angle, so on and so forth, okay, you'll notice that WY is congruent to itself. So, like so, I have three sides. Here is your S, S, S. Okay? Alright, part D. Again, this is something that I'm going to have to give you guys because we haven't learned it yet in class. You'll notice that I have, okay, these angles are congruent because of parallel lines. They're called alternate interior angles. We'll talk about that in class soon. So we can say angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and they're also telling us that side AC is congruent to side OT. Okay, so here's something interesting. Do you guys see any other angles that are similar? Some of you might be able to say, hey, in the middle right here, 1, 2, 3, 1, 2, 3. There's actually two answers you can give me for this one. You could say ASA. Remember in class how I said, like, take your fingers and pinch them? Okay, that's ASA. But you could also say angle, angle, side as well, AAS. Either one works for this one. And it is possible to have multiple ones that work. Okay? Cool. On to the last one here, part E. I have a triangle AME on top and triangle ETA on the bottom. Now, again, hopefully you guys are seeing this, but in the middle, I have these sides are congruent. So look what's going on here. AT is congruent to ME. I have AE is congruent to AE. And I have angle T, that's not T, is congruent to angle M. So at first glance you might go, oh, this is that SSA one that we can't have because, you know, we don't want that one. But what kind of triangle is this? It's a right one. Okay? This is our special HL, hypotenuse leg. I have a leg right here and I have my hypotenuse. If you have those two things congruent for a right triangle, bingo, you got it. You can say HL. This is a very specific one, and it pops up pretty much 90% of the time when you have a right angle. Okay, so when we see that 90-degree angle, that's what pops up in our head. But all in all, this is what we got so far. I will make up additional reviews for you guys. We should be in good shape. But that about wraps up our chapter. Might be a few little things here and there, but for the most part, we should be in good shape. If you guys have any questions, feel free to ask in class, and we will go over this and make sure you are all 100% comfortable. And as always, keep up the good work. We are all counting on you.